So my next guest today is Shantanu Joshi from a company called Koki. Nice to meet you.
Same here. Nice to meet you, Trevor.
Okay. So Koki's been around for many years. It's a very well-known name in the industry. Tell me a little bit about some of the key alloys that you have that are different from some of the other providers.
Sure. So we have lead-free alloys and leaded alloys. So in the leaded alloys, we have standard eutectic alloys.
Yeah.
We have eutectic alloys, which is like 2% silver, and we have some anti-tombstoning alloys as far as leaded products go. When we talk about lead-free, we have low-cost, high-reliability alloys. We have high-reliability alloys without bismuth. We have high-reliability alloys with bismuth.
Right.
We have high-temperature alloys, lead-free alloys. So we have a lot of different alloys that we can
That's
play
quite a
with.
combination you've just listed off there, ranging
Yes.
from some low-temp alloys using bismuth or not, and then you said anti-tombstoning. What alloys are you using for that?
So anti-tombstoning alloys, basically, we use it in the leaded applications, which has kind of a little bit of antimony
Okay.
that helps the parts to stabilize more and
Yes.
give that anti-tombstoning characteristics. So
Okay. Interesting. And then you've got a very interesting material as well, which is using formic acid.
Yes.
It's not using flux, which is really
Yeah.
quite interesting. So try and explain in some detail to our viewers what
So
that is.
we have a product which is designed for formic acid vacuum reflow. So pretty much formic acid does is it's a reduction agent. So it basically acts as if it's a flux. So it's going to reduce the oxides on the substrate
Yeah.
and the component
Yeah.
and make sure that the surface is solderable.
Right.
So the paste basically is, I would say, a little bit simple, meaning that not a lot of ingredients in the paste. It's pretty much the solvent.
Rosin-free.
It's a rosin-free paste, activator-free paste. So there is nothing that remains after the reflow is completed.
Right.
So it's actually a zero flux residue paste. So the advantage of that is it's basically you don't need to clean it, and then it's ready for potting if you need to pot afterwards.
Right. And this is typically used in sort of power applications.
Yeah, typically right now we are seeing like IGBTs, MOSFETs being basically using this technology, but I think this technology is going to be used in the standard SMT as well in
Yes.
some years. So.
Yes. Okay. Is this a new product that you brought out, or is it?
Yeah, this is a newer product. I would say we launched the product about 12 months ago or something. So it's kind of a newer product for us, newer market for us for electronics. But we are getting a lot of inquiries out of that. And then I presented a couple of papers, this in SMTAI as well as Apex last year. And we are keeping on doing the development for this and basically trying to do some reliability tests to see like if it actually is compared to a standard solder alloy that we see. So
I would imagine it'd be cost effective against other solder alloys as well.
yeah, I mean the cost effectiveness comes where you are going to replace the preforms. So as you know, the preforms, the standard size preforms that are readily available. But then if you change the die size, you need to change the preform size. So the initial cost for preform is very high if you don't have the correct size of preform.
Yeah.
So where we shine is that the solder paste, which is designed for formic acid reflow, all you need to do is cut a new stencil. Pretty much it prints like a standard paste. You can use it like a standard paste.
Right.
But because there are no activators or rosins in the paste, you need formic acid to do the reduction reaction.
Excellent. Okay. Well, that's a really interesting product. Does it got a name or a
Yeah, we call it E series.
E series?
E series.
Okay.
So that's what we call it.
Good. Okay. And do you have any other products that we should be talking about?
Yeah,
Something else.
think I would say like these days, because the silver prices are going very high, we are getting a lot of inquiries on low cost, high reliability alloys. So basically they want to replace SAC 305 with something which is cheaper in cost, but they don't want to compromise on the reliability. Whether it's a thermal fatigue reliability, drop shock reliability, they want to make sure that the alloy can actually like able to replace what we have with the SAC 305. So
Right.
we have a couple of options there where we reduce the amount of silver and then we add alloying elements to make sure that the alloy is strengthened.
What sort of alloys are you using to?
So we add little bit of nickel and bismuth to make
Okay.
sure that the alloy has precipitate strengthening, solid solution strengthening to make sure that
So the bismuth gives it some strength, but the nickel gives it some
I would
some
say,
elasticity,
yeah,
maybe?
bismuth is basically depending on how much percent of bismuth you add. Obviously, it reduces the melting point, but because the bismuth crystal is different than tin, it basically acts as a barrier for the crack to propagate. So we call it a solid solution strengthening for
Right.
bismuth. So we add that, and nickel basically makes the alloy tougher. So
Yes.
we definitely add that as well. So.
Okay, interesting. Well, you seem to have a range of really interesting products there. I want to thank you for coming in and telling us about them today.
Thank you for having me.
Thank you.
you.